And you always want your part to be very clean before you go back to the surface plate. Okay, clean the... You can use your bare hand to wipe down the blued area on the surface plate. The Canode paint cleans off very easy from your hands with water and soap. You don't want to do that with the die cam. Otherwise you look like Papa Smurf, which is ridiculous when you're 2 meters tall. Okay, we rubbed it, and before we flip it over, we hinge it. And it seems like you can also use just a pen and drop it on the part while you hinge it and watch the motion of the pen to find the hinge point. Feels, yeah, about here. And over here, okay, over here we have this corner high. This corner is high. So flip it around, take a look at it. This corner is high, and this corner up here is high. So we're just attacking this area here. We're trying not to scrape too hard into the area here, which we did before. And we ignore all the other bluing again. Okay, I knocked down the high area from the last pass. And when you look at the hinge now, it's rotating around this point. Pretty much. And same on this side. Almost like here, so that's pretty much 33%. So now we know that the blue that we get here is the actual bearing pattern of the part, because it's not rocking back and forth. So now we attack all the blue areas, really all of them. Okay, I scraped one more pass and I got pretty much one blue spot per square inch. If we take our gauge, this is almost 4 to 5 points per inch right now, except for this area here. This obviously is low because there is not a single high spot in there. We could go on and scrape semi-rough all the blue for 2 or 3 passes down. This will take forever, so we can do something that's called blind scraping. We will scrape everything except for this area 1 or 2 times. Just hitting the whole surface with the scraper, removing a little bit of material. And that's what we're going to do now. And now we offset 90 degrees and go a second time, still ignoring this area. And in this stage you still can stone pretty hard without doing any harm. I went on 2 passes more by hand, and this is what I would consider reasonable flat to proceed on. When I take the gauge with the 1 inch by 1 inch window in it, no matter where I move on this test piece, I will always find a high spot, a blue spot in the window. So that means the bar is reasonable flat, and I can confirm that on the surface plate. The most obvious thing to check the flatness is of course the bluing, but as we saw earlier, this can lead to misunderstanding or to fake bluing because the part is rocking or tipping or something stupid like that. That means we have to find a way to validate our bluing. For example, hinging the part. And when I hinge the part, you see that we're rotating around these points. That gives us already a very, very good indication if the part is high in the middle or not. Then you can go by sound and feel. You knock the part with a plastic hammer or with a copper drift or something like that, and you listen. If it bounces, you will hear it, and that means there is a hollow, that it's also tipping. And what I like, it's a bit slower, but what I like is to use an indicator. I place an indicator on top of the part in different areas, and I press down on it. You do this preferably on the ends, because if the part is hollow in the middle, you cannot, depending on the part's geometry, you will have to bend down the part, but mainly we want to see if the part is rocking. And you do this, for example, in all corners, then you have a very good idea what's going on. And this part is pretty darn solid flat. You can also use some feeler gauge, stock or a feeler gauge, as thin as possible. My thinnest is 0.04 of a millimeter. That's 1.5 thousandths of an inch. So this is pretty thick. So in this state we don't need this anymore. But when you go around the edge of the workpiece in the roughing state, you can find hollows pretty easy that way. Just going around checking if there is something stupid going on. And one last thing you can do to check if it's high in the middle in this direction, you can use a 1, 2, 3 block, for example, or any other ground block. Place it on top. Make sure it's clean and stoned well, and hinge the 1, 2, 3 block and check where its points of rotation are. This looks pretty darn good. This is a little bit harder to identify, but also a good way to do it, and it helps always. The problem with hinging the part is it's hard to hinge, for example, a dovetail or a prismatic way, because it's locked in one direction. There's only so much degrees of freedom if you're working on a slide way. You have to find other ways to check for bow. But as I said, with the dial indicator you can check a lot by hinging, by hammering down on the part. You have to find a way to verify your bluing. Otherwise you make a pretty blued surface, you scrape it until it's very pretty blue, and all you made is a nice rocking chair. Doesn't make sense at all. So now we continue on. Now we can stop roughing and go a little bit finer. Before we go on, it might be a good idea to resharpen our carbide insert, because we did a lot of roughing now, and I feel it already getting dull. You can check it just like a sharp blade. When it peels off, a nice chip from your fingernail, or when it catches on your fingernail, it's pretty darn sharp. Or when you run your fingernail along the edge, you shouldn't feel any imperfection in this curve. So this is this is my scraper blade sharpener. It consists of an old high-speed bench grinder, 3000 RPM, 150mm diamond wheel from eBay China. They come in different grids. They are 150mm in diameter. This is a 1500 grit. Mounted on here is a 3000 grit. And they are cheap. I think they're about 10 to 12 bucks, free shipping from China. And they work really good. They leave a nice crisp finish on the carbide inserts. I started to use this also for sharpening carbide tooling for the lathe, for example. So we take our carbide out of the scraper, and this is really just cobbled together. The bench grinder is bolted to an old piece of wood, and I have a rest in front here that's just screwed on, and it's shimmed in the back so it's 5 degrees up towards the blade like this. And that's all you need for scraping cast iron. 5-degree negative and a surface where you can rest your blade on, just like this. We'll turn on the grinder and just sweep the curve like this, sweep it like this, done. Once you have the 5-degree negative on the blade and you use always the same rest to regrind it with the same setting, regrinding goes super fast and there is not much need to do heavy roughing anymore. Yeah, this grinder doesn't run super smooth. It wants to move away on me, but that's fine. Let it move. Just using a little bit of glass cleaner for lubrication. Then you check your grind, and surface finish is really pretty darn good with this blade, or with this grinder. There's just a piece of phenolic as a support for the thin sheet metal diamond wheel, and that's it. Took me about an hour to cobble it together, and while it looks really cheap and stupid, it works quite well. Surface finish on the carbide is what you would expect from a proper carbide grinder. Now we are at the point where we can scrape a little bit more refined than just scraping paint off. Until now we really were going in and removing a whole lot of material. Now we can start to create something that's generally known as checkerboard pattern. We will create individual scrape marks that do not touch each other in one direction. Then we come back and we place another row of those scrape marks along the surface, and that will in the end create something that looks a little bit, if you hold it up against the light, it will resemble the classical checkerboard pattern that we see on old machines. But we will not blindly go over the whole surface. We will try to identify again the real area that need scraping. We will leave, for example, this here. We won't touch this because it looks a little bit low. We won't touch this, not this. This is also not good. We might leave something like this away. This doesn't look too high too. But apart from that, maybe this here too. So we will leave the green areas, the green zones, unharmed. And put a nice pattern on the remaining ones. We shorten the length of our stroke now too. We are not going to use a 20mm long stroke by hand anymore. We maybe reduce it to something like 10 millimeters, 8 millimeters. That way the pattern will also get more even and the surface will get nicer. Okay, that was first pass. Now we go clean it and blue it. Okay, it is pretty hard to film or show bluing on camera, so I had to turn off two of my overhead lights, and I bumped up the ISO sensitivity of my camera, so now it should show up pretty good. And I used the canode a little bit and I rubbed it heavier. So I went on a few passes just using short strokes and removing the areas that were heavy blue. And as you can see, without having to do anything with the high spots itself, I got already a pretty good bearing there. When we take our 1-inch square here and we place it here, we can count the bearing points. 1, 2, 23. This is 24 over here. 1, 2, 3, 4, 19. This is 19. Out here we have maybe just 121. And out here, this is the worst area. 1, 2, 3, 16. So 16, 24, 19, 21. We're getting there, even without having to do anything special about trying to hit points. Okay, speaking of high spots, it might be time to explain the meaning of the bluing. Let's say we have a surface plate down here and we roll down a layer of the blue paint, no matter if it's Dicam or the canode or Prussian blue or whatever, some non-drying blue. Then we have a workpiece that has a roughness to it. For example, this crater landscape I drew up here. And when we take the workpiece against the surface plate and we rub it, there will be blue around these high spots. It will collect around the top of the high spot, and the high spot will have a very faint bluing, surrounded by a very heavy ring of bluing. Some of the not so high spots will get some bluing. They will have a relatively dark blue on the top, and depending on the height of the valleys, some of the very low high spots might even get a little bit of blue. And when you check out the bluing of your workpiece, you have to keep those in mind. You have low high spots, medium high spots, high spots. There is another kind, super high spots, where the color on top gets polished off completely. So that's I will remove this, blue up this workpiece and show you what I mean. Here we have a good selection of the different high spots. We have a light blue surrounded by very heavy blue around it. All these are pretty high points. The bluing gets rubbed off the top of the high spot and gets squished around it. and that creates this ring of heavy blue around it. Then we have lighter glue points. These are about medium height. These here, they are blue, but they don't have a heavy ring around them. And here. This is a very, very low high spot. This one is only very faint blue and is pretty much below the surface of these ones here. And you want an average to be most of your points like this. Like the high spot surrounded with the bluing. That's what you're aiming for, and that will give you a good bearing. The percentage of bearing is the relation between the surface area of the high spots in a certain area to the low spots, like this. Low spot is everything that's not covered by blue after you rub it. That's a low area. And only the high spots are bearing and carrying the load bearings. And you want for a sliding surface like a machine way, about 50% of bearing surface. You can change the percentage of the bearing with stoning, but you have to be careful not to knock the surface convex or concave when you do the stoning. Now, as we have a bearing across the whole surface, we can start to pick out individual points and scrape them. We would take the scraper and just remove high spots like these. This will take some time. If you have to do a full pass of this takes really some time. That will create basically a complete new pattern on the bluing. Slightly lower, and it will increase the bearing surface because points like these that are very faint might come into contact then. Yeah, and that's what we're going to do. But you still have to get a nice pattern, you have to follow the rule of the individual scrape marks. You want to do this and not do this with your scrape marks. This will end up as a very horrible surface, especially not only for visual, but also when you glue it up. Because this will, in the end effect, will create a full high spot. This will create a hole. And at this point it gets really tedious. I already did one pass, knocking down all the high spots, and as you can see, this looks pretty darn good for just a practice piece or demo piece. I changed to a 40 radius blade, and I will do one more pass and then I will call it done, because this is just a demo piece anyway. I don't want to put too much work into it. So let's go. And if you see a very large high spot, you can also split it in two. It just goes through the center of it, like this. And you have to decide on the fly which you consider a high spot or a not so high spot, otherwise it will take forever. Okay, that's what it looks after the last pass I did. I will leave it there. You could from now on improve it piece by piece. That's really the basics of scraping something flat. You need a scraper, you need a surface plate, you need a way to sharpen the scraper blade. And you need some high spot glue. And patience. And patience. And seeing me hand scrape, that's also the reason why they invented the power scraper. With the power scraper, this goes so much faster. So I think that's enough for a first episode on hand scraping. I plan to do 1 or 2 more videos. In the next one I want to show how to align surfaces, how to scrape square and parallel. And also how to use a power scraper. At least the basics of using a power scraper. I really have to say thank you to Mueller Nick, who brought the matter of scraping in back to the mind of the hobbyist in Germany. Back a few years ago, when he did a very good post about rebuilding, when he started to rebuild a small surface grinder and when he rebuilt his Myford cylindrical grinder. He figured out very much of the scraping by his own, and he got it pretty darn good, really. And he has a lot of videos where he does aligning and measuring. And those are worth checking out, even if Nick is not doing videos right now. But I will put a link down in the description to Nick's channel. Also, big shout out to Mr. Richard King. He's really a wealth of knowledge and a genuine good guy. I learned in the class really a lot from him, and I'm glad I had the opportunity to do some hands-on learning with him. It improved my scraping quite a bit, I think, and it made me faster, which was the main reason I went there. And yeah, if you want to learn hands-on scraping, try to get into one of his classes. It's a lot of money, but if you have some interest in it, it might be worth it. So check out, I think it's handscraping.com. I will also put the link down in the description to Richard. And yeah, he's not going to do the classes forever. He's planning to retire. So yeah, thank you all for watching and see you next time.